question that I really think encapsulates combinations really good is the following. You have five fruits: apple, banana, cherry, date, and elderberry. You want to pick three of them to make a fruit salad. How many different ways can you choose three fruits? Well, if you think about it, okay, we have room for three different fruits in our salad, and we have five to choose from. Okay, so maybe we have five to choose from here. So five, and we'll have four different left, so four, and three here. So if we multiply these together, we get 60. However, if you think about it, given our three slots, let's say we ended up choosing apple, banana, and date. I guess the date is brown, I don't know. So, in our selection, we have apple, banana, date. But now, if you know anything about permutations, the the 60 we have here is where the order matters. So in this final count here, it's saying that this is a different salad than apple, banana, date, or date, banana, apple, and that it's different from um, date, apple, banana. These are all counted as different salads. But if you think about it, it's all mixed up in the same salad. It'll taste the exact same. The order you put the fruits into the salad doesn't matter. It's all the same thing. So we shouldn't be counting all of these um, different versions of the salad. And just to sort of write this out more, we can write out even all the different permutations for just three different fruits. So we can have banana here, banana here, banana here. That makes all the six types of banana salad orders, and apple here, apple here, apple here. Don't worry about what I'm doing, just sort of get the idea. So given three fruits, we could make six permutations, say perms, but all of these is the same salad. Let's draw like a bowl with apple, banana, and date. It's the exact same thing. It'll taste the exact same. So what I'm getting at is for every six permutations, we only have one combination. Combination. Comb. In which case, the order doesn't matter. With permutations, the order does matter. We're trying to find every different order. Here it doesn't matter. We're just trying to find that three fruits can fit into one salad. And so our original estimate on how many different salads we can make is wrong, right? It's not 60, but it's 60 divided by 6, right? Because for every 6 permutations, we only have one combination, so it's 1/6 of our permutations. So really what we found at the start was the permutations, and we're dividing by 6 to find our 10 combinations. And now intuitively we figured it out, but just like permutations, there is also a formula for combinations. And given our example, it'll be pretty intuitive what it is. So the number of combinations is n factorial over r factorial times n minus r factorial. And now if you know the permutation formula of n factorial divided by n minus r factorial, well, you can just see that part of the combination formula is the permutation formula, which makes perfect sense considering in our original example, we calculated for our 60 permutations and we just divided by 6. So we had our permutations and we divided by, in this case, our factorial, which was 6. So it's all about getting our permutations and sort of refining it for where the order doesn't matter. That's the intuition behind it. So if we redo this same question given this formula, well, n is, I guess, the fruits, the number of fruits that we can choose from. And r is the amount of fruits we can choose, right? So our ordered selections that we can fit, I guess, into our salad is a better way to say it. Selections. And so just as explained, r in this or n in this case would be 5. We have 5 fruits, and we need to pick 3 of them to go on our salad. So the number of combinations is 5 factorial over 3 factorial times 5 minus 3 factorial, which gives us 120 over 6 times 2 factorial, which just becomes 2, so it's 120 divided by 12, which is 10, which is exactly what we got before when we divided our first guess of 60 by 6, because we had our 6 permutations for every combination. So the same result, just intuition versus formula, right? And while I always suggest, um, going based off intuition, figuring out the problem first without the formula, because if you rely too much on the formula, you'll be mixed up when something doesn't work or you don't understand what the formula means itself. That's sort of why I did our first guess first. And so, sort of key takeaways here is the combinations formula is really just the number of permutations divided by our r factorial, which the reason why we divide by r factorial is because order doesn't matter. Whereas for permutations, order does matter. That's the key difference. And just to sort of do one more question to really drive home how to use the formula and sort of intuition behind it, I will copy paste another question I have ready. Okay, so I got another one right here. And now I haven't done these questions myself. I like to figure out the questions live to sort of show my intuition, right? So to sort of get where I'm coming from instead of just figuring out from knowing the answer. So our question reads, a teacher has 8 students and wants to select 4 of them to form a committee. How many different committees are possible? So maybe it's like vice president, president, uh, treasury, and I don't know, communications. I don't know what's in a student committee. And we need to fit 8 students into these 4 slots. It's not saying um, how many different, or how, which student can be in which slots, how many different arrangements we can make. It's how many different committees. So order doesn't matter. We're just trying to find out how many uh, committees we can make. Which instantly means we're dealing with combinations. And so just as we saw with our formula, we can derive that we have 8 students to pick from, so n is our 8, or yeah, and r is 4, because we're selecting 4 of them. There's 4 places to put our 8 students. So the combinations is 8 factorial over 4 factorial times 8 minus 4 factorial, or 8 factorial for 4 factorial times 4 factorial, which if we evaluate this, becomes 40,320 divided by 4 factorial, which is, I believe, just 24, yes? So it'd be 24 squared, which as a whole is equal to 70. So we can have 70 different committees. Did I write committees right? No, there actually was 2 E's. So just to sort of reiterate, order doesn't matter. Our permutations formula, or combinations formula, sorry, is n factorial over r factorial times n minus r factorial. And to just sort of always read out the question, identify your r and n variables, think about the question, right? Writing it out, thinking about it, given the scenario, and evaluating for your number of combinations, and always trying to figure out what type of question it is first. So we figure out as combinations by the different committees. So always think about the question.